Welcome to our video series on photovoltaics, advanced analytics and artificial intelligence. Today we're going to start with the basics. Photovoltaics. How is a technology that harnesses the power of the sun transforming the way we generate energy? Solar energy is not just the future, it is the present. Let's discover together how it works and why it is so relevant. Photovoltaics is a technology that converts sunlight directly into electricity using semiconductor materials. This process occurs through what is known as the photovoltaic effect. Solar cells are typically made of silicon, one of the most abundant materials on Earth. When photons, particles of light, strike the semiconductor material, they release electrons, creating an electric current. This process, though simple in theory, is at the heart of modern solar technology. But what else makes up a photovoltaic system? Let's take a closer look at the components that make up a photovoltaic system. Solar modules. These are assembled solar cells. They come in different technologies: monocrystalline, polycrystalline, and thin film. Inverters. These devices convert the direct current DC, generated by the modules, into alternating current AC, which is what we use in our homes and businesses. Storage systems. To make the most of solar energy, especially on cloudy days or at night, batteries store surplus energy. Support and tracking structures. The panels are mounted on structures that orient them towards the sun. Some even follow the path of the sun to maximize energy production. Substation, used to convert and boost the voltage of the energy generated by the solar panels, facilitating its integration into the electricity grid and its efficient distribution. These are the essential elements of any photovoltaic plant. However, their performance depends not only on the technology, but also on external factors. Now, let's talk about the variables that impact the output of a PV plant. Did you know that weather conditions play a crucial role? Solar radiation. The amount of light a panel receives is the most obvious factor. But there are different types of radiation: direct, diffuse, and global. All of these influence the performance of the modules. Temperature. Although solar panels are powered by light, they do not like heat very much. The higher the temperature, the less efficient the conversion of light into electricity. Shade and dust. Shade, dirt, or even dust accumulated on panels can drastically reduce the efficiency of a solar system. Optimizing the production of a PV plant requires understanding and managing these factors. Now that we know the components and externalities, let's talk about the advantages and challenges of solar PV. Advantages. Solar energy is a clean, renewable, and abundant source. Each year, the cost of solar installations decreases, making it a competitive option compared to other energy sources. Challenges. Despite its benefits, PV faces some challenges. One of them is its intermittency. It does not generate power at night and is dependent on the weather. In addition, high upfront installation costs remain a barrier for many companies. Solar energy plays a key role in the transition to a cleaner and more sustainable energy system. Countries around the world are investing heavily in solar energy to decarbonize their economies. From large industrial plants to residential self-consumption systems, solar energy is everywhere. And with the help of technological advances such as advanced analytics and artificial intelligence, we are optimizing its performance. As we have seen, photovoltaics has a huge potential to transform our energy system. If you are interested in finding out how you can implement solar solutions or optimize the ones you already have, feel free to contact me on LinkedIn. We are in a new energy era and you can be part of it.